Good morning, good afternoon, and good evening, everyone, and welcome to our FDT3 and OPC UA seminar highlighting the key to interoperability. This is co-sponsored by Utthunga and the FDT Group, and I'm Glenn Schultz with the FDT Group, and I'll start out the webinar for you today. A couple of housekeeping items before we get started. Please be aware that this entire session is being recorded, and we will make the recorded version available to you after the seminar, so you may replay any part of it or share it with your colleagues as you wish. If you look at your toolbar for the webinar, you see that there's a handout session, handouts at the bottom of towards the bottom of the toolbar, and you'll find a number of handouts there. And we'll also follow up with you after the seminar with some links for some videos and things that will supplement the information we're presenting today. We will take questions from this webinar, and we encourage you to ask your questions. We'll hold all questions to the end of the presentation, at which time we will go through the questions. So you see a question tab on your toolbar. As you come across questions, feel free to type those in there. And our moderator, Maggie, will be monitoring those in the background. And when we get to the question and answer section, we'll start addressing all of your questions for you. If there's anything we can't cover during the course of the webinar, we'll certainly follow up in writing with you via email or other means. So our speakers today, I'm going to briefly introduce the topic of FD3 and OPC UA, since FD3 is a brand new standard of the FDT group, and show you a little bit on how those two have come together in our new standard. But then we want to quickly move over to my colleague from Utthunga, Smitha, who's going to walk you through some specific use cases and value propositions related to this new technology. So we're not going to use web cameras today. We'll save you from the talking head scenario, and we'll let you see the PowerPoint, but here you can see Smitha and I. So our agenda for today, first just cover briefly the state of the industry. We'll talk about what is the open integrated advantage of the FDT standards, and specifically FDT3. Security is a big topic these days, of course, especially with enterprise-wide systems, and we'll highlight some of those points for you. And then we'll quickly get into the specifics about the OPC UA part, talk about some of the keys to interoperability. Smitha will present 2 case studies for you relating to the use of FDT3 and OPC UA. We'll cover some of the specific benefits, and then we'll open it up for the questions that you've typed in into the toolbar for the webinar. So let's get right into it. So a little bit about the state of the industry. The FDT organization just released our new FDT3 standard. We've been in the industry for over 20 years, and hundreds of thousands of installations of the FDT standard exist in the industry. And there's tens of millions of devices that are supported by those various installations. But we recently updated our standard once again. And some of the things that we look at when we do this kind of activity, first, we service all of the automation markets, both process, hybrid, and factory automation. Our focal points are open integration. So we are internationally recognized as a standard with all the major standard bodies around the world. We've taken a very data-centric view of this new version of the standard, making much more data available across the enterprise, and this is what Smitha will specifically highlight for you through the use of OPC UA. We've added full mobile and remote access capabilities as well. So in the past, we've been largely a desktop type environment, although we have had client server implementations of our standard for a few years. But now with this new version of the standard, everything is web browser based. We've also addressed a much more flexible architecture for the standard, so it's highly scalable, and we'll highlight that in just a minute. It's very secure. We designed it from the ground up with security in mind. And of course, with our extremely large installed base in the industry, We also look for backwards compatibility capabilities, and of course, what we're very well known for in the industry, interfacing to all the industrial automation protocols remains a hallmark of our standard. So meeting some of the market demands with the new standard, of course, we have the issue of security. You cannot these days talk about platforms, especially enterprise-wide platforms, without having a close command of the security context. And we think we've done a very good job of that. It's standardized. This is building on top of our existing FDT standards, so we haven't started over, and it will be recorded into all the international standards bodies for their acceptance as we come up to our normal maintenance cycles with them. One of the new features is it's completely platform independent, so you can deploy this on Linux, on Apple OS, on Microsoft platforms as you wish. It is interoperable, so not only with our previous versions of the standard, but as well with all the different networks, and as you'll hear today, very much so with OPC UA. We have both web and OPC UA interface capabilities, and these can be used to extend the features of the platform by writing custom apps. For example, there'll be a feature article in our upcoming newsletter about how to do that. And it's very information driven. For a long time, the FDT standard has had access to all of the information of all of the devices across the enterprise. With this release of the standard, we've opened that information pool up so that with proper credentials, with proper access, you can use that information anywhere in the enterprise. And certainly OPC UA is a key enabler of that. And we've also taken a look at service-oriented type architecture so that we're able to extend this with apps and with other features in the near future. So a little bit about our advantage from an open integration perspective. This diagram is our new FDT3 architecture that supports the industrial Internet of Things. And I just want to highlight a couple quick things here for you. Central to today's conversation, you'll notice in this FDT server, which is this blue rectangle here, you see that there's an embedded OPC UA server, and we'll talk about that much more extensively in a few minutes. There's a web server here that takes care of all of the browser-based activities that users can have either on a local basis or working remotely from their facility. Certainly in today's COVID environment, that's a hot topic and a very nice feature to have. And any major brand of web browser can be used here. We can also do analytics through these connections. Smith is going to extensively cover some possibilities for OPC UA, and of course we can do enterprise applications as well. We've taken care of getting the access to the drivers for the standard by storing them all in one location in the cloud, so that any server that needs a driver for a device, we call those drivers DTMs, are able to automatically download the correct driver from the cloud without any user intervention. The server itself, as I mentioned, can be on any of the major operating systems. The same installation instance will work on all operating systems, and you can deploy this in the cloud, on-premise. You could still deploy it as a desktop application if you wish, on the edge of the enterprise, and so on. So we designed this so that we've got this organized as an FDT Industrial Internet of Things platform so that it can support all the new initiatives that are coming along in that area. It's a single server environment, so you do not need to deploy this across multiple desktops. You can have a single server take care of a facility or an entire enterprise. It's highly scalable, so the architecture is designed so that maybe you're a manufacturer of a bottling line, for instance, and you'd like to put remote access for asset management into that bottling line to support your customer. You could put it in a small Linux card in that environment, or you could scale this up to full enterprise-based cloud systems with tens or hundreds of thousands of devices supported. The security is built in, and we'll cover this just in a minute here. As I mentioned, it's completely platform independent, so it's not bound to Microsoft as so many standards are. You're able to deploy this on any of the major operating systems. It has built into it a native OPC UA server, and of course we'll cover that in great detail shortly. The web server is embedded in it as well, and we keep our capability for universal device integration across all the different industrial networks. We support our vendor community that uses these products in their product line or would like to have their devices supported by the FDT architecture. We do that through toolkits that in the FDT terminology is called common components. So it's a toolkit for the vendors so they don't have to spend a lot of time on the nuances of the standard. That's all built into the common components, and they can focus on the value add for their devices or their systems that they're integrating. A few key features about our FDT server. It has the integrated web server, which gives you a full browser-based environment, no more desktop-type environments. It completely modernizes field device management, so you're able to, through a smartphone or tablet, as you wander through a facility, access devices and check up on them. It transforms the OT access for remote asset management, and certainly with COVID, we hear this over and over again that people are not able to get into all the facilities that they'd like to, and that remote access is absolutely essential going forward. Key to today's discussion is our embedded OPC UA server. We leverage a very standard OPC UA server so that any OPC UA client can access that server as long as it's authorized. This enables the IT and OT side of your facilities to be integrated with real-time data. And of course, the same connection path supports ERP, MES, CMMS type applications for complete enterprise connectivity. And we also support OPC UA Pub Sub, and one of the examples that Smitha will run you through here shortly is exactly that. The security is key here. So we've used industry standards for security that are well accepted both in the IT and OT organizations. So we use TLS as the standard, and we use 509(b)(3) certificates for authentication. And we've taken security to the point where we can not only authenticate the user, but if you choose to, for your facility, you can also authenticate devices that a user may use to access the system. And of course, we maintain our traditional role-based access control so that you're able to categorize employees according to the role, and their security privileges follow that. And in our industry, many of the industrial protocols are starting to actually enhance the security on the wire for their protocols, and probably the most prevalent one in this discussion, because they've had their standard out now for some time, is Ethernet IP, so that as these networks become more locked down from a security perspective, we'll continue to be able to support those networks with the FDT standard. I mentioned the FDT DTMs briefly earlier. These are the device drivers that support all the devices that are connected to the FDT3 system. And I bring this up here just so that you have an awareness. This is where all the information that we're about to talk about with OPC UA comes from. So the vendor creates the DTM for their device. It has all the device-specific data and functions. There's all the business rules contained inside of there so that you can't set configurations that simply make no sense or that are out of range and those kind of things. It handles the communication from the driver to the network, and any internal dependencies are addressed as well. And it also contains the user interface at UC. So it really is the representation of that device in your browser as you interact with that device or its settings. Inside of these DTMs, there's both a web user interface and there's also a business logic. There's a number of different kinds of DTMs that are available within the standard. The most common one are device-specific ones, but there's others that, for instance, handle all devices for a particular network. An example of that would be what we call an interpreter DTM for the HART network, where it can simply interface with all the devices that are supported on the HART network. The inside of that DTM has a lot of features in it, and I'm not going to go through this. I just bring this up to make you aware that these are the interface points that we use to be able to provide the information that you're seeking through OPC UA. So these are functions and interfaces that are already built into our standard, in most cases have been there for 10 or more years, and we've simply enhanced those and integrated that into the OPC UA data model so that this information is available to you from any OPC UA client, as Smitha will show you in just a minute. So this is built in to our FDT server architecture. We have the OPC UA server and any client can connect to it. The way we do this is through our common components. So these are those developer tools that allows our vendor community to develop IIoT ready solutions. They're platform independent tool sets. So even the tool sets themselves are platform independent and directly support generating the necessary components in a platform independent fashion. And they're all out of the box ready. So we have common components for the FDT server. Some people will still want to deploy a desktop version of the application, perhaps for backwards compatibility. So we have common components for that. And then we also have common components that help device vendors build these drivers for their specific devices. And those are called the FDT DTM common components. This OPC UA integration that we're talking about today is built in to our common components, and it's automatically enabled. The real pleasure of this for the device manufacturers is they do not need to do anything special to make their device compatible with OPC UA. Simply by making it compatible with the standard, the OPC UA features are automatically enabled, so there's no additional coding, and all of their data is presented through OPC UA. This is all done in a modern development environment, so the web user interface is HTML5 and JavaScript, and developers are free to competitively differentiate their products through the standard. We do not lock them down or tie their hands in that regard, and you can also, as an end user or a vendor, develop custom apps as well. Touch once on security here. Oops, I'm sorry. Oops, pardon me. Touch on security. So from an OPC Foundation perspective, I think many of you are familiar with them. It's another global nonprofit organization similar to the FDT Group. Their focus is on sensor to IT, enterprise and cloud integration. It's been well recognized for a number of years. We are very pleased to work directly with the OPC Foundation to be able to enable these capabilities in the FDT standard, as it did require some close cooperation of these two large standards organizations to make sure it worked the way the end user community expected it to work. And I think now we can say, you know, we're happy to have this essentially de facto enterprise integration standard directly built in to the FDT standard. So how we did this, if you're familiar with OPC UA, just briefly, this is the model that we use to be able to map the information that's available from the FDT standard into the standard data models that OPC UA requires so that all clients are capable of accessing that data. So the types of things you see here, it's basically a data information driven model. So we have live data is one of the things that the FDT standard is very good at presenting. We also have alarms and health information that's available through this model as well. So specifically for the FDT standard, here's what happens under the hood, if you will, just briefly. So we have these DTMs that are written by the device vendors. Inside these DTMs are the business logic that controls all the activity of that device driver. That business logic supports a number of interfaces that I showed you earlier required by the FDT standard. We essentially tap into those interfaces and map that information into the OPC UA data model. From there, it is interfaced to our OPC UA server that is built in to our common components, and then that is made available to any authorized OPC UA client. You can browse the full project structure that's inside of the FDT server application, and you can drill down to any device-specific information that you would like, and it's completely independent of what network it's on. As an end user, you won't even have an awareness that this device is on one network and this device is on another network. We make that all transparent to you, and it's as if you're speaking directly with the end device, getting the data that you're looking for through OPC UA. So this is a real-time activity. We support this in distributed architectures for single and multiple facilities. So you can aggregate all this real-time data through OPC UA that you just saw from a single facility, or it could be an enterprise-wide view if you prefer. There's a FDT DTM for any device that you want to support. That driver gets loaded into the architecture. You can deploy this as you wish in the various formats that we've talked about, and on different operating systems, even if you wish. And we do fully support cloud-based applications, so you can have your various networks in your facilities. All of that data can be securely leveraged through a cloud-based instance of the FDT server. And the data is all real-time information exchange. It's live data from the devices. As long as they're on their control network, the server will get you the live data via OPC UA. So it's a very nice, clean, easy to use feature of the standard. With that, I'd like to turn the presentation over to my colleague at Utthunga, Smither, and let her run you through some specific use cases as to how this is actually deployed and what the benefits that can be realized from it are. Smither, I will turn it over to you.
Yeah, thank you, Glenn. I hope all of you will be able to see my screen now. So greetings to all of you. So in my sessions, I'll be talking more specific about how the combination of FDT 3.0 and OPC UA is going to play a key important role in the interoperability in the manufacturing industrial space. So it will be followed by 2 case studies from FlowServe and Utthunga based on FDT 3.0 and OPC UA. So OPC UA is considered as de facto standard for secure and reliable exchange of information between the systems, whereas FDT 3.0 offers a single server environment for the entire enterprise. FDT acts like a universal device integration standard, which is independent of the various communication protocols, including the nested communications, and it has a support for 16+ communication standards, including the proprietary ones. FDT technology is independent of device types Like you can have a DTMs for your IO modules, for your drives, for the sensors, actuators, positioners, or any type of device profiles. And it is independent of the instrument suppliers as well. So with the FDT 3.0, it is not just limited to the Windows platform. So as Glenn mentioned, it works for Linux as well and any other mobile platform. So technically, we can have a FDT 3.0 server in a Linux box or hosted in an enterprise server. With this, FDT technology is an open integration standard with built-in security. So when we combine this FDT 3.0 with OPC UA, it brings all the assets from various vendors supporting multiple communication channels into unified device model, which simplifies the communication and also enables the enterprise-wide integration. So I'll be talking more about this interoperability topics in my next few slides. So as per the recent survey of the global industrial IoT gateway, it is going to grow by 1.12 billion in the next 4 years. So these I'm not talking about the automation gateway or a protocol converters here. These are the industrial IoT gateways, which actually fetches the information from these PLCs and sensors and pushes it to the higher level enterprise systems. So it uses various communication model like MQTT, AMQP, or a REST API. And the most sophisticated ones also have a built-in OPC UA server capability in this industrial IoT gateway. So, however, in this current industrial gateways, the OPC UA server information model that is exposed via these for these devices are vendor specific or communication protocol specific. So even though the generic OPC UA client will be able to fetch this information from this industrial gateways via OPC UA service, but in order to interpret these multiple device information model, it has to have a proprietary tools or a proprietary logic in the software. So this poses scalability issues when you have a multiple devices connected to the industrial gateways and you have a industrial gateways from multiple vendors. So in future with FDT 3.0 standard, these industrial gateways can have a FDT OPC UA server information model enabled. So this brings the unified device integration standard model to be enabled by this OPC UA client. So in this case, any devices that you connect to this industrial gateway, which is we will be able to fetch that information by FDT aware OPC UA client in a more harmonized way. So it will be independent of the supplier, independent of the communication channel, and making it much more asset lifecycle management easy. So in this way, FDT 3.0 and OPC UA enables the unified device model. Now, so integrating these field devices into the higher level systems is key for attaining the operational efficiency. It's very important to have the plant KPI information available in the hands of those who would like to make the data-driven decisions. However, there is a huge challenge in making these data available in these things due to a lot of interoperability issues. We will have in this diversified ecosystem, we have a different sensors, host suppliers, DCS vendors, IoT service providers. And it's very important all of these things to work seamlessly. But in case of a FDT technology, all these device vendors will provide the device DTM, communication vendors will provide the communication DTM, and there are more than 20 plus FDT enabled asset and device management tools that is available in the market. So all these things work seamlessly, exposing the information via FDT enabled OPC UA information model. So it actually provides the harmonized view of all the assets that you see in the shop floor. And all this information will be exposed by these asset management systems for various reasons. The data will be processed and you can have a unique use cases supporting it. Whatever I'm talking about is not just in the PPT. FlowServe actually has done a case study on this, which we will be showing it later in this session. So this is not just in the PPT. So FDT 3.0 and OPC UA, it actually simplifies the communication from the field device to the upper layer. As you can see here, this is like a real world example where you have a hard field devices which is connected to the host system or DCS systems via a gateway. So technically the process values that is being fetched by these devices will travel as a hard network packet, and it will reach this gateway, where this hard packet will be embedded in a Profibus packet, and then it will be fed to the FDT system. So FDT systems interpret this data using the Profibus gateway DTM and hardcom DTM, and it will be able to fetch this information that is being read from this device. And it exposes this information as a OPC UA node in the OPC UA address space. Any OPC UA client will be able to fetch this information. So when you have this OPC UA client, the data that is being fetched from this field device is independent of its origin, how it has actually transferred from this shop floor to this top floor. It has gone through hard network, it has gone to Profibus network, but when it comes to here, it is just the data that what matters to the upper layer systems. The advantage of using OPC UA is not just it passes the data value, but also the metadata information associated with this data value. Like for example, if you take a process value that is being transmitted from this field device into this OPC UA client, so it is transferred as an analog item type by this OPC UA node. So that means that along with the process value like a temperature, it will also be associated with its unit, its EU range, its LRD, URD cutoff. All those information will be exposed and bundled and will be shown. So in this way, the OPC UA client at the other layer will be able to make a more informed decision and can interpret it in a much better way. So this is an advantage of having the OPC UA in a capability in the FDT world. And also in this case, in this OPC UA address space, it is like FDT OPC UA information model also allows the information that is being fetched from this field device to be grouped as a functional group. So when we have this information, we can expose it in a more meaningful way, in a more to have a better, good user experience. For example, all the parameterization information that can be grouped as a functional group. All the device identification information can be categorized as a device identification functional group. So that the OPC UA client, when it reads the data from these devices, it is not just the flat list of data, but it also has more meaningful and structure to that data. That's how the FDT3 and OPC UA brings the capability to the field. So now I'll be talking about two case studies. So this is one of the case study that was presented in SAIS event in Japan last year. This is one of the research that we have done. We also had done the prototype of this, where we have combined FDT 3.0 along with OPC Pub sub mechanism, and then we saw how it can add benefit to the asset health monitoring use cases. So as you can see here, in the FDT 3.0 architecture, as Glenn has mentioned, the OPC UA server and web server, these are the two ways that FDT 3.0 exposes the information. Via OPC UA server, any OPC UA client, even the generic one, will be able to fetch this information and get the data. So what are the information that is available? You can find the device identification information, even the topology information if you want to rebuild it at the client layer. You can parameterize the data. It is not just read. You can, if required, you can also enable writing. You can see the number health status, device diagnostic information that you can find it via FDT OPC UA information model, and also the audit trail information. and also the device images and the documentation that is associated with these devices that is available or given by the FDT DTM vendor can also be passed to this OPC UA client via more meaningful way. So when it is here, it is, even though it came from multiple vendors, device type, communication channels, but when here it is just the pure data which is required for further processing. So on the uplink layer, this is how the FDT 3.0 architecture is. So OPC UA client definitely makes a difference, but when you combine with OPC client server architecture with the OPC Pub Sub. So what is this OPC Pub Sub? In 2 years back, in 2018, OPC Foundation released part 14 of the OPC UA standard core specification. OPC Pub Sub specification is in addition to the OPC client server architecture. It is not in replacement, it is in addition to the OPC client server architecture. And OPC Pub Sub stands for OPC publisher and subscriber pattern. So how is going to work, and how is it different from the client server architecture? So in case of OPC client server architecture, as you can see here, it is required for the server to maintain a client session for each client that it connects to. So it works very well when we have a series of data that needs to be fetched by this OPC UA client. So it is the client which pulls the data from this server, okay, and it works very well in such cases. But as you increase the number of clients, then the server has a resource constraint because it has to maintain the client session for each client that it maintains to. And so in this case, the client and server are tightly coupled. So because of that, it is not scalable. So where OPC UA is being considered as the standard, even by the recommended by Industry 4.0, in order to support that IoT use cases, OPC came up with the Pub Sub architecture. So this is in addition to the client server architecture. So in case of a Pub Sub architecture, the publisher module can be integrated into any OPC UA server or a client application. So there can be publisher module and the subscriber module. So you have the existing OPC UA server application, but with this publisher module, you will be able to get the information of whatever is your interest. So in the OPC Pub Sub world, it is called as topics. What you see in the colored nodes are something of interest. So that is called topics. So the interested topics will be published by this publisher module to the broker. So, and then it will be given to the interested parties who will subscribe to this information. So via OPC UA, with the same address space, when you want to have this information, so the information that is exposed by OPC UA server can be given to any subscriber or any amount of data that can be given. So OPC UA the public and subscriber uses the push mechanism. So only whenever there is a change in the node, or you can configure it to push the data to the broker. So it is completely loosely coupled. And OPC publisher, OPC Pub Sub module also has a inbuilt support for messaging protocol like AMQP or MQTT. It is not that AMQP and MQTT are competing with OPC. OPC actually complements with these AMQP and MQTT protocols. In case of Pub Sub module, it's not only the message-oriented broker system middleware, it can also be brokerless as well by using the UDP protocol. So you need not have a broker. If we have a broker, it can be even a software module or it can be a hardware module. So with all this flexibility and the scalability that it provides, the OPC Pub Sub is being adopted very well in the industry. In the just a span of 2 years, it has got very well acceptance in the market. So now when we map this to the our asset health monitoring use cases, now we have all these field devices and we have a FITS OPC UA server here. So from a various, you can FITS OPC UA server can be from the various vendors. And with that OPC UA address space, we have built an additional OPC publisher module, which publishes this data to a broker. And any asset health monitoring application will be able to fetch this information and then show it here. So in this case, it is kind of a pull mechanism from the push mechanism from the publisher side. So subscriber will be given the data only when there is a change in the asset health monitoring applications. So in this way, it is like also OPC Pub supports two type of data set messages. Like it is like in technology, it is called key frame and delta frame. So only when there is a change in the data, even though you say that I'm interested in these data, but you can just pass the data as a delta frame, so that only the information that is being changed will be pushed. So in this way, you are reducing the data traffic hugely. So in this case, especially with the asset health monitoring, where you are just monitoring the data and especially you are monitoring the change in the data, this has been a very helpful use cases. So benefits of combining this OPC UA Pub sub with FDT 3.0 based on our research, we have actually listed down. One is like in case of asset health monitoring, which is a subscriber in this case, can retrieve the required information model from the cloud platform without any knowledge of the publisher, which could be a FIT server which is publishing the data, or it could be any proprietary software which just publishes the device health status. For subscriber, it doesn't matter. So you can have a very different types of application pushing the data to the cloud, and as a subscriber, you are just seeing that information. So it brings a huge amount of interoperability related. It solves a lot of interoperability related challenges. And while second one is while transmitting the data via OPC, it is not just values, it is the complete information about that. So that the subscriber can interpret that information correctly. And even in this case, the publisher and the subscriber need not know each other at all. So they can be anywhere in the system, and as long as they have an access to this broker system, if you are using a broker. And also this publisher, which is nothing but a FITS OPC server, or anyone who has an access to the devices or a data source for which we are publishing the data, and the subscriber need not be their lifetime need not overlap. The publisher can just push the data to the broker and terminate. So the data will be available to the subscriber application, which can take it later. So so this brings a huge benefit when you want to look into the event history of what happened with the device's health status. And also the thing is, it is independent of the cloud platform. Like if you are using a cloud platform of Azure or from Amazon services, or you are using the AMQP or MQTT protocol, it is independent of that. So this enables the existing application to easily adopt the technology with very less investment. So in this way, we felt that OPC Pub sub with the FDT 3.0 is a very good combination, especially for asset health monitoring applications, where you are just monitoring the data only on need basis. So another case study that we have is from FlowServe, and it is based on the real world use cases like remote connectivity and asset monitoring using FDT 3.0 and OPC UA capability. At the end of these sessions, FDT Group will also be sharing the video link of this case study, whatever we are seeing now. So in this prototype from FlowServe, they have two case studies here. One is they have a FDT 3.0 OPC UA server for remote asset health monitoring and for monitoring the remote asset health monitoring and possible remedies, which is they are fetching via OPC UA interface. And they also have a FDT 3.0 web server based interface for remote diagnostics, parameterization and commissioning. So it is the complete DTM capability again that is possible remotely using FDT 3.0 web server. But in this, I'll be focusing more on FDT 3.0 OPC. here. So the setup here is like there are 10 flows of devices and the FITS OPC UA server that is located in USA and which feeds the data to this FlowServe web portal. So the device, so as you can see the device health status, most of the devices luckily are in the very good health conditions, and but the two of them needs your attention, which requires which is showing that out of specifications, and one which requires the maintenance. So when we go more deeper into this, you'll be able to fetch more information about this. Along with this more health status, you will also be able to see some of the more important parameters associated with this. So in this case, the warning information is maybe because of the valve stability due to the low friction, and you'll be able to see that information in the dashboard. And as you can see here, you can go more deeper into the device health status, where you can look into the LRAMs that actually got generated and the possible implications of that and how you can actually resolve it. So in this way, you will be able to take a very better decisions, and also helps in improving the maintainability of these devices. You can also get more information about a valve health here. And apart from the live information, you can also feed the information related to the event history. So it helps us to know what has happened over a period of time in the devices. As you can see here, it is not just the device health information. FDT OPC UA information model also has a inbuilt the device images. Also, you can see it here, which is exposed via FDT OPC UA information model that is available in the web portal. And also, if you have any attached documentation, which could be a user manual associated with device, also can be exposed via OPC UA information model. Here, the web portal actually uses this information and exposes it. So with this, actually, FDT 3.0 DTM, via web server, it uses the responsive by design. So this is like complete your DTM capability that you see with your existing FDT 1.2 or 2.0 DTM. You can have it enabled in a web mode. That means that it works in the mobile platform, in the tablet platform, or in a big desktop applications. And it aligns itself, so it is responsive by design. So that the user experience that that FDT offers is not compromised. So based on this analysis by the FlowServe on doing this on this prototyping, they have understood the benefits of utilizing the FDT 3.0 DTMs using the OPC UA connectivity. So some of them is like existing DTM systems can be used to push the data to the web portal. It requires a little modifications, but it is not that huge change. So you can use the existing infrastructure and make it OPC UA enabled to push the data to the enterprise system. And as a device supplier, as Glenn mentioned, you don't need to do any development. Additional development is necessary to expose the information as a OPC UA. It will be handled by the FDT Server module, which has an inbuilt OPC UA support. Single FDT3 applications can push the data via OPC and web interfaces to support different use cases. So it is like you have the information that is modeled by the DTM. So you have all the information about your devices. Now, based on how you want to use the data, you can have a OPC UA interfaces and have a separate app specific based on the OPC UA interfaces, or you want to do the complete commissioning of these devices, then you can use a web interfaces. So it is scalable even for a simple app to the enterprise level application development. And as I mentioned, FDT is not limited to Windows platform. It can be accessed via phones, tablets, without compromising on the user experience, and with the help of responsive design capability that it has taught. So live demo of this case study exists, and it will be shared as part of the kit by the FDT group. So In summary, combining FDT 3.0 and OPC UA offers a variety of business benefits, both for end users, device vendors, and host suppliers. With OPC UA, it provides a secure remote connectivity to asset in a more standardized way, and also across the firewall. You don't need to worry about the firewall. Usually in the industry, it will be a demilitarized zone where the OT network will be there and the IT network will not really have a very good access to it. But OPC, by taking care of with OPC, it will actually resolve that problem. So it also supports the harmonization of the information that is received from the assets, even independent of various communication channels. Like when the data that is being received is you are just information, whether it is received from a IO module or whether it is received from a vendor A or is it received from a profile-based network, it doesn't matter. At the end of the day, you got the information that is required, and that's how the information is harmonized via FDT and OPC combination. Works for simple application for a specific use cases. As I mentioned, you can actually have a FDT enabled applications which for just monitoring all the devices that need some maintenance. You can develop an app for that. Or if you want to have your DCS systems enabled with the FDT, it also works there. So even from like similar to OPC, where you can have an OPC in your sensor, and also you can have an OPC in an enterprise layer. FDT also has brought in that feature of getting it acquainted to wherever it fits in. It fits in very well in both of these horizon. And both FDT and OPC UA supports multiple platforms, so it enables a lot of mobility and the flexibility. It simplifies the asset management life cycle, and it's not just limited to process automation industry. It works for hybrid automation, factory automation, and it supports various deployment scenarios. Like you can have a like now you can start like how you can even have a FDT enabled industrial gateways. You can have a FDT enabled application in your tablet. So it provides various deployment scenarios. So you can have a FDT server alone, and then you can have a multiple FDT client application. It's an easy migration from current FDT installation base to FDT 3.0. So there will be an upcoming webinar that is planned from FDT Group and M&M. Glenn will talk more about that. And also we will be doing some webinar on FDT development in the month of November. We'll be sharing more details about it. So I hope this webinar was helpful for all of you to get insight into the capability that FDT 3.0 standard and OPC UA offers. Now the floor is open for question and answer sessions. Feel free to type in your questions.
Smitha, thanks very much. That was a great presentation. I'll give you a chance to catch your breath there and open up your questions pane. I've had the luxury of looking at them while you were talking, so I've got a few I can take while you get caught up here. Smitha mentioned that we do have a developers seminar coming up on October 7th and 8th. If you have an interest in actually developing DTMs or server-based applications, I'd encourage you to take a look at that workshop. It's a webinar style workshop, and we have a number of our subject matter experts that'll be presenting on various topics during that seminar. You can simply visit the M&M software website for that and sign up for that if that's something of interest to you. So let me dive into the questions. We've got a lot of really good, insightful questions, obviously some close industry followers here. So let's see if we can get through a number of these. If we can't get to yours, we'll follow up in writing so that you get the answers to your questions. Let me start with an easy one. What does FITS stand for? That is an acronym that is for the FDT Internet of Things Server. So we use the term FITS essentially on a commercial basis, and when we do that, we're really referring to the FDT3 standard. Another related question on the basics of FITS is, what is the FITS core server? You saw that on the earlier graphic. The core server is all the key functionality in an FDT server that makes it compliant with the standard. We make that available as a common component for developers to incorporate. So for instance, if you're a DCS vendor, you might take that FITS core server common component so that you can integrate FITS into your overall DCS environment. And you can then wrap value add around it as well. So you can integrate project management structures, security credentials, those kinds of things. So you extend that core server with your unique value propositions. But the common component for that core server is complete enough that you can take the code, compile it, and you have a fully functional FDT server as a result. So great question there. Let me take the next one that kind of comes towards me, Smitha, and then I'll let you see if you want to answer any of these others here. A question about the FDI standard, Field Device Integration Standard from FCG. The question is essentially, there seems to be overlap and perhaps even competing things here from an FDT, FDI perspective. Well, first of all, the FDI initiative is actually partly owned by the FDT Group. We're one of the owners. A number of foundations are the owners of that standard, and so it's a cooperation between several foundations, including, by the way, OPC UA, interestingly enough. So we do not see it as a competing standard. We see it as complementary. We have specifically worked together to make sure that the FDI standard is compatible with FDT. And so there are DTMs in the marketplace where you can take an FDI device package, which would be roughly the equivalent of a DTM in our environment, in the FDT environment. You could take that FDI device package, and this special DTM will process that device package just as if it were an FDI host system. So we do work on these compatibility issues together to make sure that things can work together so that people can choose the best solutions for their environment. And we envision that continuing into the future. So it's a good cooperative environment, and we appreciate that as foundations in the industry, our job is to serve the vendor and end user community in that regard. And Smith, let me just take one more here, and then I'll let you take any others that you think you would like to address. One question about, there's other information models. So we've talked about the FDT DTM business logic is essentially providing the information into the OPC UA information model, but there are other information models that are starting to emerge in the marketplace as well. Both of the ones that are mentioned here happen to be process automation centric, whereas we are a broader perspective than that, but these are two important ones. One is called PADIM, which is Device Information Model, Process Automation Device Information Model. And the other one that was asked about is NOA-IM, NOA-IM, which is the Nemours Open Architecture Information Model. I believe I have the correct references for those two. And the question is essentially, what are we going to be doing with those? Are we merging? How are we going to address those different information models? And we definitely will be working with those models because they're two important emerging models in the marketplace. The good thing is with PADIM, the work is well underway, if not actually complete now, to integrate PADIM into an OPC UA information model. And that's a key project point for us because obviously we'd like to see that happen as well so that we benefit from that defined integration before we start to work with it ourselves. And similarly, we're looking closely at the Nemours Open Architecture, overall architecture, not just the information model, but the entire architecture, because I think it's pretty clear when you look at the FITS architecture, the FDT3 architecture, that it meets many of the key criteria that Nemours, which is, by the way, I'm sorry if you're not familiar, Nemours is a European, primarily German-based end user association in the petrochemical market, and they do a lot of work with defining standards and requirements for their industry. Very nice leading organization. And so this Nemours open architecture model, you can see that the FDT 3 standard fits very well into a lot of things they're trying to accomplish there. So we'll have more about that next year, about those two specific information models, the PADIM and the NOAA information model. Watch for more information coming from us in 2021. Smith, is one of these questions one you want to take here?
Yes, Glenn, there are many. So maybe we will cover a few of them in this session today. So one of the question is how a basic OPC UA client can make use of the DTM user interface and the business rules done. Do we have to redo that in our new OPC UA client was the question. When it comes to the user interfaces that you expose by DTM, you can use the FDT web server. So that is a very easy way to handle that instead of going via OPC UA. But in case of OPC UA, you can have all the parameterization informations that is more relevant with respect to OPC UA use cases. So you have to choose between these interfaces based on your specific use cases. So another question is like how the vendor specific information is being handled in FDT OPC UA information model. So in case of FDT OPC UA information model, you can you can do many ways. One is your FDT OPC UA information model allows you to have a static function. So you can have a static functions associated for your devices, which actually exposes the vendor specific details. So once it is a static functions, it will be exposed via FDT OPC UA information model, so that you can have that as part of the OPC UA client, and without even instantiating the DTM, you'll be able to fetch that information. It's a very easy way to do it. Another question that we have here is how to configure the OPC publisher module. Yes, so in case of OPC Pub sub mechanism, you have a OPC publisher and subscriber module configurator tool. You can there is a GitHub. You can download the OPC Pub sub source code from there, from OPC Foundation, and which also comes up with the OPC Publisher configurator tool. So that allows you to configure your publisher module in terms of how you want to transmit the data and what information that you wanted to transmit, what are the messages, and all those things you can configure it using that OPC Publisher configurator tool. So you can experiment with it. You can just download. It is freely available from GitHub, from OPC Foundations. So there is a publisher configurator model that is available. And maybe another one is maybe meanwhile, Glenn, do you want to take something, because
I have take one, Smith, and give you a second to look at them there. So the question was asked, does the FDT 3 server support firmware updates of field devices? And an example is like can open. So to be very specific about this, the server itself doesn't have to directly do that. It's actually the DTM for the device that would have that responsibility. And the server will support that activity as long as the DTM is capable of doing firmware updates. So if you've seen DTMs, if you've used them before, you're aware that there can be a wide variety of functionality that the vendor can include in their DTM. You know, it's just really the sky is the limit. There's some absolutely amazing DTMs out in the marketplace in terms of what they're capable of with diagnostics and updates and so on. So if the protocol supports it and the device DTM supports it, our standard will allow them to do that firmware update. Let's see. Smitha, did you have another one you wanted to tick off here?
Yeah, one is is the FDT hub available? Maybe Glenn, you can give more information on that. It is already available. That is
Sure,
easy
we're just putting the wraps on the interfaces for that. You can already request subscription to the FDT hub. And again, just for refreshing the memory here, the hub is the repository for the DTMs. This has all been organized and prepared so that the DTM vendors don't even have to do anything to get their DTMs up in the server. So we've thought a lot about our vendor community in terms of making it easy for them to manage. So when they go through the certification process for their DTM, once they get their certificate saying that their DTM is indeed compliant with the standard, their DTM is automatically made available up in that FDT hub. So watch for the announcements of going live here shortly. We're really excited by it. I've often said it's one of the most commonly requested user features to make easier access to DTMs. And we think we've just hit it out of the park with this formula. So watch for the formal release announcement shortly.
Glenn, I would like to take one. The question here is it required to have a cloud middleware broker to which the subscriber is connected, or can this whole concept also be executed at on-premise level only? The reason is that the majority of the process industry is not ready for the cloud application yet. So you're absolutely right. It is not necessary that you have to use a cloud-enabled middleware broker. You can go with a software broker which just can communicate between the two systems. And if you don't want broker systems, there is also flexibility that is provided by OPC Pub is brokerless services, where we can use the UDP protocol for communicating between the machines. So in this way, you can have a horizontal machine-to-machine integration using OPC Pub capability. So to answer your question, it is not mandatory to have a cloud-enabled middleware broker for subscriber or publisher to make it enabled.
Let me take another one here, Smitha. And this one sounds like somebody that is from the industry. What is the refresh time of the FDT OPC UA server in the example of the HART device? Do you continuously pull data? If yes, what's the influence on the network load? Well, using HART as an example is kind of an interesting one, because HART, from a protocol perspective, classic HART, is really the slowest of all device communication protocols that's in the marketplace. So you could easily choke a HART device simply by constantly requesting data from it. So there's other methods, but generally, if you're an OPC UA client, you should be gating your data access requests. And I think this is where Pub Sub is very nice, because you don't have to keep hitting the server to get data refreshes. You'll be informed when there's a data change. And in other cases, the DTM itself may throttle that access. But as always, these are very complex network environments. Many of the FDT environments support 2, 3, 4, or half a dozen different networks in one facility. And so you always need to take the time to go through network loading, the need for either the PLC or DCS to have priority access to devices that should be thoroughly reviewed in the throttling set accordingly, so that you maintain proper control and yet get the information access that you'd like. Smitha, did you want to take one?
Yeah, so one more is FDT 3.0 works for Android platform as well? And yes, the answer is yes. It is built on .NET Core, which is a platform independent, and the prototype has been already done for Linux environment, and it should be applicable even for Android as well.
Great.
So another one is for a non.
Go ahead, Smitha.
Yes, go ahead. Okay, sorry. Go ahead, Glenn.
Okay, the question is, what are the communication protocols currently supported by FDT3? So we today support more than 16 standard industry protocols. And because of the way the standard is architected, vendors can also support legacy protocols that might be specific to their product line or specific to a served geography. So there's actually more protocols than the 16 that you often see on our material. So when we released the FDT3 specification, we immediately released the updated HART and Profibus protocols with it, and we are currently working on additional protocols. You probably have seen that the ODVA Foundation has announced cooperation with us to update the SIP protocol so that Ethernet, IP, DeviceNet, and so on are completely compatible with the new FDT3 server. And you'll see us continue to release a number of other protocols over the coming months. I would say if you are an end user or vendor that has a specific priority that you would like to see because of some large use case, please feel free to inform us about that, because it might be possible we can alter our priorities depending upon the situation. And a very related question, Smitha, that I might as well take right away is, will FDT2 communication DTMs work with an FDT3 server? And the answer is, if there is not a need for a graphical user interface, that's generally a workable scenario. We actually did a fair amount of the testing that way ourselves early on with the common components. So as long as you don't have the need for a graphical user interface from the server to support that communications DTM, that should be a workable scenario. Obviously needs to be tested, but it's quite plausible.
Yeah.
Smitha, did you want to take another one, or have we pretty much run through the questions?
I think we have run through the question. I have some difficulty in looking into the questions. It's showing in a small window.
Oh, you can undock that and it should be able to expand. I see one here that's kind of an interesting one that just popped up. Let me try to take this one while you're doing that. Can OPC UA TSN, boy, we do get a mouthful of acronyms these days, complement FDT3 standards? So this is a great question in general, not just for OPC UA TSN. So time-sensitive networking, TSN, is certainly a hot topic in our automation industry these days. It is a standard that really complements Ethernet in general. It makes it much more deterministic, and you can schedule traffic and so on the way you need to. So it's got some great features, and really I think it's fair to say that any network association that has an Ethernet-based protocol is seriously engaged in a TSN initiative of some kind. And the same for OPC UA, because obviously most of their network backbone is Ethernet in that environment. TSN serves OPC UA very well in addition. So from our perspective, every network in the FDT standard is defined through what we call a protocol annex. These annexes are independent of the main standard itself. And what's very interesting in the way the standard was architected, and it's been this way since the beginning, the FDT group realized early on that there will always be new network standards emerging on the marketplace, major updates to networks and so on, and that it would not be sustainable for us to say we have to re-release our standard every time one of these networks changes or is enhanced. And so the architecture is very cleverly designed so that the servers that are out there in the marketplace, without being changed, can take on a new protocol. It's a very interesting architecture. So this allows people that are writing these communication protocol annexes for our standard to look at a new standard, and TSN being one of those, TSN on Ethernet, to look at that and say, okay, we need to add TSN now capabilities. And they can go off and write that document. And when that's completed and voted on by the FDT Group membership, any products that are compatible with that document, like gateways, communication cards, and so on, automatically get integrated to any existing FDT3 server applications out in the marketplace. So you will see us definitely take on TSN capabilities, and to your question, it'll definitely complement the FDT3 standard because it gives us more network compatibility, and it allows the end users to benefit from all the great things that TSN brings to the table. Great question.
Yeah, so there is one more question. How does the FDT 3.0 differentiate itself from the concept like MTP, where information model, data models, and HMI models are described as well? For me personally, to be honest, I'm not quite aware of MTP model. Maybe we'll look into that and then we can answer it as part of our follow-up things.
Okay,
do you
great.
know? Yeah.
I think, Smitha, we're a little over our allotted time, and I think we've gotten all the questions, but we can certainly review them afterwards. And if we missed your question, we'll follow up with you on that question.
Yeah.
So, Smitha, I want to thank you for hosting this event today. It's been great. It's nice to see such a leading development company like Utthunga be so active in what the FDT3 standard is capable of doing, and we look forward to more great things from your team.
Yeah. Thank you, Glenn. Pleasure is ours. Yeah.
Thank you, everybody, for attending.